All right, good morning, everyone. Thanks so much for coming. Just again, my name's Jeff Hurd. I'm an affiliated researcher here at CBCS. Before I kick off today, I'm just going to give a very brief acknowledgement of country. So I'd like to acknowledge the Yagara and Turrbal people as traditional custodians of the land on which we meet today and pay our respects to their ancestors and elders, past and present. We have the great pleasure of welcoming Yiwen Zeng, Dr Yiwen Zeng from the National University of Singapore, who's joining us today, specifically from the Centre for Nature-Based Climate Solutions. Yiwen is a conservation ecologist and geospatial modeller whose work on climate change and biodiversity loss seeks to balance environmental and socio-economic considerations. We're going to hear today about the promises and pitfalls of scaling up biodiversity conservation post COP15. So thank you, Yiwen, and I'll hand over to you.
Right, thank you. So thank you for being here today. And yeah, I feel very lucky that I managed to get a slot to talk to everybody today. So I'm a research assistant professor. I'm one of the PIs, the principal investigators over at the Centre for Nature-Based Climate Solutions. And we do a range of work at the centre, mostly centered around how we can use conservation efforts, protection of forests, restoration of forests to scale up nature-based, to scale up climate solutions in specifically around the Southeast Asian region, but beyond as well. So I'll talk a little bit about what my lab is doing, which tends to be a little bit more towards biodiversity conservation and policy. And specifically some of the work I did related to COP15. So we all know that the world is facing this biodiversity crisis. There's tons of species that are being lost, and we're probably going to lose a lot more. That's not new. As a policy mechanism, the world is trying to invest more towards conservation. So the UN Biodiversity Conference is one of the largest ones that's around. It concluded in December 2022, relatively recently. And it came up with the Global Biodiversity Framework to sort of guide conservation efforts towards 2030 to 2050, depending on which targets and goals it is. It replaces the IG biodiversity targets, which ended in 2020. So you see there's a little gap over there, two-year gap. That's because COVID happened. I'm sure everybody's aware of that. Yeah, but basically the delays and some issues associated with that. And I guess one of the major featured outcomes, right, of COP15 is this 30 by 30 goal. So this is sort of our center my talk today around. And the idea is 30 by 30 is to protect 30% of the world's terrestrial and marine areas by the year 2030. Over 50 countries, well, back then, over 50 countries have already committed to 30 by 30 even before COP15 happened. And then the whole idea is that each country would expand its protected areas to 30% domestically. That was within the commitments that the US, Germany, and a lot of other countries made. And the idea behind protected areas is that it's a clearly defined geographic space that's recognized and managed through legal or other effective means, right? Specifically for the conservation of nature, ecosystem services, and cultural values. And this comes in. This is important because it's sort of how we frame the research for the next part. So the whole idea is 30 by 30 for protected areas. This was some of the work we did previously. We focus specifically on terrestrial ecosystems and try to measure what the benefits of 30 by 30 is. Specifically, the whole idea behind it is that expansion of protected areas can be guided by many objectives, right? And choosing where and what to protect is influenced by the whole idea of trade-offs and benefits. So, the research question we ask is, what do we gain by expanding protected areas if selection was guided by different objectives? So I'll break down these objectives later, and it gives us an idea of what we can get. So the first step in this whole analysis is to figure out, first of all, how far away we are from the target. So this was work done in 2020. So the idea is that in the year 2020, there was over 270,000 individual protected areas and over 800 other effective area-based conservation measures. So this includes indigenous areas, community managed forests, and some other national parks. that covered about 17% of the world's land area, according to WDPA, and this is actually in line with the IG targets for 2020. The idea is that each country would commit to protecting 30% within their country's boundaries as part of this 30 by 30 goal. So we try to calculate the protected area coverage per country, and this is what it is. Basically, the countries that exceed the 30% line are the ones that have already exceeded 30% protected areas on their land areas, not the sea areas. And then based on all the countries that have not reached it, we can calculate the gap for each country. So currently there's about 2.7 billion hectares of forests of areas left to protect to hit this 30% goal. So the next step was to try to figure out where to place new protected areas. And for this, I'll use Singapore as an example because I'm extremely biased. So the whole idea is that currently Singapore has about 10% of protected area coverage, right? If you wanted to protect another 20% of the land area, we can think of several areas of where to place this, right? So how do we pick where to place these protected areas? We can place it in somewhere that is the least disturbed, right? So places that are far away from everybody else, it does not have that much damage currently. So in a way, it's a way to preserve ecological function. But at the same time, we can try to find a place that has the most number of wildlife species as a way to preserve the most number of species. And then we also can figure out places that has the greatest amount of ecosystem services and place the protected area there. So all these maps were basically guided by degree of habitat disturbance, species richness maps, as well as ecosystem service values, right? So these ended up serving as our objectives, right? Basically, the least disturbed habitats, the most number of species, and greatest amount of ecosystem services, these are all guiding objectives that allowed us to try and figure out where we could place potential new protected areas. So for this, we needed maps because I'm a geospatial guy, I like to use maps. And again, very biased. So we basically needed 3 groups of maps. One is a measure of the degree of habitat disturbance, one is species richness, and ecosystem service values. But as we all know, there are many ways to quantify all of these criteria. So what do? First of all, we focus on the least disturbed areas. We use 3 different indices of disturbance. One is a human footprint, which I'm sure everybody here is really familiar with. The ecosystem intactness, and biodiversity intactness. All of them are measuring things, similar aspects of the same thing, but have slightly different spatial configurations. And we also looked at the most number of species. So there are many ways to measure species richness, right? We thought about total species as a way to measure. We thought about the amount of threatened species. We thought about species range variety, which is an indication of the level of endemism. Right? And we also thought about key biodiversity areas. And last, for ecosystem services, because they are pretty hard to quantify, we only use 2 indicators. Right? One was climate change mitigation, and the other was nutrient regulation. And I'll talk a bit more about how we calculated this in the later slides. But I think what is important to note is that all of these 9 maps are actually not mutually exclusive. There are areas where they do overlap, the areas selected do overlap, and these areas basically can provide, can represent undisturbed habitats and also provide the most number of species to conserve and provide the greatest amount of ecosystem services at the same time. So it's sort of like you get to achieve all 3 at the same time. So then the next step is to figure out what we could gain. So going back to the definition of what protected areas are, we focus specifically on nature and ecosystem services. And the whole goal was to evaluate the benefit of placing protected areas in the specific configuration across the landscape. So we measured the number of unprotected species that will gain protection. So they were previously unprotected, and with the creation of new protected areas, they will gain a protection that did not exist before. So that's how we measure that additionality in that case. And we also looked at the amount of CO2 emissions that could be avoided or removed from the atmosphere as another measure of ecosystem services. And we also looked at the amount of nitrogen pollution that is retained within the vegetation that maintains water quality. So this is basically water quality and climate change mitigation as the 2 ecosystem services we will measure. So how do we calculate these? So species, the whole focus around here was for species that are currently not in protected areas to gain a level of protection. And for this, we use IUCN. IUCN grid list has a nice polygons that are sort of validated and verified by experts in the field for each of the individual taxa, and we focus on birds, mammals, and amphibians for this study. So the whole idea is that each species range map would overlap with the maps from step 2, and based on that, we can calculate which species gain a protection that it did not have before. Right, and for carbon, so the whole idea is that when you protect an area, right, we can prevent deforestation, but also allow the area to regenerate naturally. So these were the two scenarios we focused the climate change mitigation around. And we created maps of avoided emissions as well as carbon sequestration around these ideas. We looked at terrestrial peat swamp and mangrove forests as our key areas of mitigation. And we also calculated carbon pools of both above and below ground biomass as well as soil carbon. And for all these, we use existing maps and we edited existing maps. And then last, we tried to calculate the amount of nutrient regulation that could be provided by nature areas. And this was data obtained from the INVEST model that Chaplin Kramer produced in 2019. So I lucked out, the data was already there and I used it. All right, so what did we find? So the first step, well, we went back to step 2 and we looked at the guiding objectives. So the least disturbed habitats, the most number of species, and the greatest amount of ecosystem services. We broke it down to the 9 different maps that correlated with this, corresponded to that. Then we figured out how much we gain for each of this. So we looked at it for biodiversity, climate change mitigation, and water regulation. And let's focus on species first. Well, we find that out of there were a total of 1,693 species that are currently not protected by any protected areas at all. What we find is that if we sort of focus on least disturbed areas, it gives us the lowest level of, is there an area? Sorry, I'm trying to get a laser.
It doesn't work yet, the point.
Okay, thank you for that. So what we find is that for the least disturbed habitats, we get the least number of species that we could actually protect. They are currently not protected. And then we focus on the most number of species as a guiding objective, and we focus on the greatest amount of ecosystem services. We tend to get more species that we can protect. So this represents about 45 to 58% of the maximum biodiversity benefits. The maximum being all the species that are currently unprotected, right? If we looked at most number of species, we can actually get up to almost 90%. And if we looked at greatest amount of ecosystem services, this gives us up to about 83% of the maximum biodiversity benefits. So we converted this to percentages, just so that it's easier to compare across the other groups, because it's a similar metric then. And we looked at the maximum theoretical climate change mitigation being 38 billion tons of CO2 per year. And this is roughly what the breakdown is. Of course, if we sort of maximize for the greatest amount of climate change mitigation, we would get the greatest amount of climate change mitigation. So I guess that is nice because it confirms that we are going on the correct track. And as well for nutrient regulation, the greatest amount is provided if we sort of prioritize for greatest amount of nutrient regulation. So I guess the main thing to focus on here is that range size variety. So if we try to preserve the most number of endemic species, if we hit by the 30 by 30, we actually can get almost up to 91% of all the species that are currently unprotected to be protected. For climate change mitigation, we can get about 60%, and for nutrient regulation, we get about 47%. Other things to note is that if we prioritize biodiversity and ecosystem services, it actually provides us with the greatest amount of gains, right? So if we go down the route of payment for ecosystem services, for example, right? It's promising because it shows us that we actually can get a decent amount of gains from associated with biodiversity at the same time. And if we looked at the least disturbed habitats, we tend to save fewer species. So least disturbed habitats are sort of representative of those rock and ice scenarios where people end up conserving places like in Alaska, where there's a lot of ice, a lot of rocks. There's not really that many species that it supports in that area. So we tend to get lesser ecosystem services and species conserved in those scenarios. But those could represent areas that are cheaper to conserve because they are really areas that nobody tends to use. So this gives us the global benefits. If all countries committed to 30 by 30, But I think one of the questions that people ask is, should we really stop at 30 by 30? The whole idea behind this is that there is this half Earth proposal where we eventually want to save 50% of the Earth if we want to, preserve commensurate amount of biodiversity. And some people have proposed this 50 by 50 as the next step in this 30 by 30 goal. So we also calculated what happens if we try to protect 50% of each country's land area. And what we find is that the greatest amount of increases actually comes from the ecosystem services itself rather than the species, because a lot of the species would have been preserved if we hit 30 by 30 already, a larger percentage. So the amount of delta we gain by hitting 50 by 50 will actually be reduced. But there are also many on-the-ground considerations that we need to think about, right? We get potentially large gains and increasing protected area coverage by 30 or 50%, it requires a lot of careful consideration. Importantly, there are many social economic impacts of increasing protected areas. For example, it can interfere with local land rights. It might result in the displacement of local communities if it's not placed well. And it could disrupt local and traditional livelihoods as well, right? And this also is interlinked with leakage, where the creation of new protected areas in one location could displace human pressures to another location. So that actually just pushes out the level of deforestation. And these are really interlinked issues with ongoing implications for protected area expansion. So as a marker, as an indicator of the degree of social economic influence, we try to look at the number of people it might affect. So we just use a human density map to try to figure this out. And what we find is, of course, in the areas with the least disturbed habitats, the amount of people that it affects tends to be less, right? But I think an important point to note is that even though it's 0.4 to 0.5% of the world's population, those are still millions of people that could be affected if we place new protected areas in these areas. So these are just serious considerations that we need to think about. If we want to hit the 30 by 30 goal, we still have to expand protected areas, but I think part of this idea is that it cannot be at the expense of local communities at the same time. So, okay, just to summarize some of these findings, most countries have to expand protected areas for 30 by 30 because they signed up for it. There are many ways to get there, but deciding on which areas to protect requires balancing of biodiversity conservation, ecosystem services, as well as social economic costs, right? And this leads us to the next part of the work that I did, which is there are many ways to prioritize species conservation. For this work, I used a very simple measurement of outcome, but biodiversity conservation can be more nuanced. So there are several things you should be thinking about when it comes to biodiversity conservation. For example, how much habitat does a species have, right? How much habitat is already protected, and are these protections actually effective or not? So this led us to the next portion of our work, which is how do we prioritize which species to protect based on these ideas? So factors that make species vulnerable are how much habitat they have, how much protection is currently in place, and how effective these protections are. Then that led us to our research question. Which species should we focus on for conservation efforts, and where do they live? This provided us with a relatively straightforward way to prioritize species conservation of the most at-risk species. So this is not really for all species, but allowed us to focus in on the most at-risk species. And it involves careful selection of protected areas that can help to maximize efficiency of biodiversity conservation. So basically, we constructed a relatively straightforward model based on these three criteria, and we converted it into step 1, step 2, and step 3. So step 1, how do we do this? So if you guys are familiar with the area of habitat measures, this is simply it. We started off with the IUCN range map polygons that we had before. So imagine this is a hypothetical bird. This is its range size that we get from IUCN itself. Thankfully, there are existing maps of habitat classification, and IUCN classifies it accordingly as well. Everything is standardized, so it gives us a very easy metric to work on. And then we can take land cover maps from Young et al., which is already optimized to the classifications within IUCN. What we can do is we can overlay the two maps together. We can exclude the areas that are outside the polygon, as well as a habitat that does not match the species preference. So this gives us, at least according to IUCN, the area that the species can use as habitats or prefers to use as a habitat. And we can calculate already. Based on this hypothetical bird has about 136 cells of habitat. So gives us our first answer. The second one, how much protection does it have? For this, we can actually just use the WTDPA database. So this is the world database on protected areas. It allows us to overlay where the protected areas are currently and calculate the percentage of the habitat that is currently protected. So we can find that 26% of the habitat falls within protected areas, and this gives us our second value. And for the last one, right, how effective is this protection? So for this, we actually went to the PADDD database, which looks at the downgrading, downsizing, and deconsentment of existing protected areas. So the whole idea behind this is there's a change of legal status, and we use this as an indicator of protected area loss, right? So loss of the protection that's currently in place. So currently we find that for this hypothetical bird, about 3% of its habitat falls in an area that has lost its protection. Right, and based on that, we have 3 matrices that we can try to figure out how we can evaluate the degree of threat. So we repeat this across all the different taxa, all the different animals, and based on this, we can already try to understand our results. Sorry, many animations. So okay, how much habitat? This gives us our area of habitat. How much protection? This gives us our proportion of habitat in protected areas, and we can plot out where these species lies already. So when we try to expand this across all the species that we analyzed, right? Before I show the results, one way to understand this is the less amount of habitat available means it's more prone to extinction because it basically has less habitat to use. And then the less amount of protected area means it's more vulnerable to human pressures because there's no legal framework keeping people out, right? And then this is basically a hex-bin plot, which is a 3-dimensional histogram, where the darker color basically represents a more number of species that sort of lie within each of these categories. But what is most important to note is that species that fall within this area are species that desperately need protection because they have very little amount of habitat left, and there's no protection over their habitats. And the species up there are basically species that are extremely dependent on protected areas because if the protected area fails, there's nothing keeping people out from the last remaining bits of habitat that they possess. And the one other interesting thing to note is that if we look at the distribution, we actually can see that at larger area of habitat, it tends to be more unimodal, and then it goes to more bimodal at lower areas of habitat. All right, so we also find that this is sort of reflected in the extinction risk already. So if we look at IUCN's categorization of extinction risk, for critically endangered, and vulnerable species, we tend to see a higher concentration of species that fall within these categories. So higher threat status means more species have less habitat, and they fall within the extremes of both over 90% and less than 10% protected area coverage. So one other important thing to note is that 1,463 species, or roughly 30% of the species analyzed, actually lack sufficient protected area coverage, right? And 70% of these species are already threatened. So the next step is to try to figure out then, looking at the effectiveness of the protected area against how much habitat they have. And based on this, we can plot it out again. And this gives us an estimate, right? Basically, the species that have lesser amounts of habitat, again, is more prone to extinction, but at the same time, species that are more affected by PADDD events, pet events, they tend to be more prone to extinction as well because they are in places that have lost a degree of protection. And a lot of the reason for this tend to be towards human activities and the conversion of a protected area to an infrastructure project or maybe a mining project sometimes. And what we find is that basically, if we look at this, it tends to be correlated between the area of habitat and the amount of protected areas affected by PADDD events. Yeah, and then the relationship is actually more pronounced for species that are more threatened. So it's sort of reflected inside the assessment of threats already. Right, and another important point is that about 37% of all the species analyzed actually live in parks that are already affected by PADDD events. So the potential conservation impact of these events is pretty high. All right, so based on this, we can determine the amount of habitat measured against the PADD events. We also can look at the amount of habitat against the protected area coverage. And from a conservation intervention point of view, basically these are the habitats that you want to improve management over, the protected areas that you want to improve management, and these are the areas that you want to create new protected areas around, right? So this directly correlates or ties back to the COP15 goals. Next idea is to figure out where we can actually implement this. So we focus on these two, and we focus on the areas that the species that have the least amount of habitat, because we know that less amount of habitat means more threatened. All right, and this gives us two maps, right? Basically, it allows us to identify areas that are the most at risk under these two. And another important point is that total, this is 900 plus species. This species only utilizes about 8.4 million hectares globally, and this falls in less than 1% of the world's area. So what this means is that if you really try to be very efficient about how we protect new areas or improve management over existing ones, its area cost itself, the amount of area it actually has to take up, is pretty low. And if we just do things really efficiently, there might be a way to conserve at least the most threatened species. So summarizing, right, the whole idea behind this is that it provides us with a methodological insight and a relatively straightforward technique to try to prioritize species conservation. It has potential for high conservation efficiency, and we can safeguard about 912 species with just less than 1% of the world's land area. But of course, this requires very careful planning and implementation. But it might allow us to try to maximize benefits that comes out from the 30 by 30 goal. And the last part I will try to cover, not spending too much time, is how we can fund all these protected area expansion. And this is also again reflected in the COP15 goals, where conservation is very costly, right? The whole goal is to try to close the conservation finance gap of up to 700 billion a year. And there are some sort of ways that was proposed. I'll just focus on one that I have worked on quite a bit. And this is the payment for ecosystem services, specifically carbon credits, right? So the whole idea behind carbon credits is that it also allows us to try to sync up and maximize outcomes from two different policy frameworks. The other one being the COP27 or the climate change goals as well. So I don't really need to explain carbon credits to everybody, but essentially carbon credits basically allows us to decarbonize, and there's a lot of interest from private companies and a lot of interest from governments as well in their road to decarbonization. So we asked the question, can carbon markets be used to fund forest protections? And we basically did this for terrestrial forests, and we find that at the cost of about $5 per ton of CO2, we can protect up to 20% of all tropical forests. And at the cost of $5 per ton of CO2, we can protect about 10% of all mangrove forests. The important thing to note is that the price of this has crashed to about $1. So it's not a good sign because of all the controversy. So if you're not familiar, basically, there was a whole bunch of controversy around the methodology and how a lot of the carbon credits that are being provided might be meaningless because of the way it's being calculated. It's not really providing real additionality. So because of this, the price of carbon has dropped by quite a lot. But at the same time, the price of carbon for mangrove forests can be about $27 now. So it maybe evens out. The other thing is that there are also a lot of other socio-economic considerations associated with carbon markets itself. People have made such big promises about reforestation across the region, across the world, but in reality, just like the other research has shown, that it's a lot of socio-economic considerations we should be thinking about. And if we really apply all of these constraints at the same time, we find that the total percentage that is achievable drops by a lot. And with that, protected areas is one of the core strategies to try to avert the biodiversity and climate crisis. We find that the 30 by 30 goal can provide huge benefits, but it requires prioritization. You want to figure out where the most threatened species are and how we can protect them. Payment of ecosystem services could be an important way to protect species habitats, but its efficacy or its reliability is a bit in the air. And with that, I'd like to thank the following people. I'd like to thank the people from Princeton in my time there, and I'd like to thank the people from Singapore and CNCS. With that, thank you for your time and attention. You take any questions if you have any.
Thanks, Yiwen. That was really fantastic. Really impressive body of work. We'll take questions from the floor, and anyone online, please put your questions in the chat.
Yeah, hi, thank you for the presentation, Yiwen. It's great, especially when people think about 30 by 30, a lot of times they don't think about where these protected areas are placed, and this will have a drastic impact on whether these 30 by 30 goals will actually be effective. My question, and sort of like my slightly surprised that in the guiding objectives that you've mentioned for where to put 30 by 30 goals, one thing that I'm surprised that it's not in there is the opportunity cost of protection of land. So you have like 3 guiding objectives, and well, in the policy making space, a lot of times the opportunity costs of land, of development will be a huge consideration as well, especially when thinking about if countries simply neglect all these biodiversity indicators and select the 30% land that has the lowest opportunity cost to protect. Well, obviously we do a lot worse, but it'd be very, very interesting to find out how worse do we actually get, or when we're thinking about more deeply these issues, how we can integrate costs into thinking about maximizing, say, for example, cost effectiveness of 30 by 30 goals instead of just thinking about maximizing the biodiversity indicator. So what are your thoughts on opportunity costs?
Yeah, so that's a fantastic question. The simple answer is we thought about it, but simply there is no existing maps that can provide us that level of assessment that we wanted at a global scale. So 2 things. One is that the least disturbed habitat sort of reflects that. It's not entirely gets to the cost value, but it sort of reflects the areas that people are less likely to develop because people have not developed it in the past. That's not to say that that really directly correlates with opportunity cost, because it doesn't. A lot of times there's nature rents in areas that are far away that might have mining benefits and stuff like that. But the other thing I would like to say is that that's a great point, and I am currently working on it as well. So basically, we don't have any good opportunity cost maps. We are working on an agriculture rent map for Singapore, for Southeast Asia, sorry. And we're trying to get that out. And as a way to estimate what is the cost of conserving. So basically, if we go towards 30 by 30, what is the actual financial cost of it, both in terms of direct and opportunity cost? Yeah, it's not easy to come up with any of these cost maps, and especially one that is applicable and accurate at a global scale. It's been quite tough. So yeah, we sort of sidestep the whole issue for now. Yeah. It's a good question. Yeah.
Maybe just to follow on from that point, and thanks again for the presentation, it's really good. I guess maybe you could think about with this evaluating like the productivity of land from say an economic perspective to put into that equation. Something that's often used that does have global coverage as a proxy sort of for economic activity is night lights data. Actually, so I don't know if you thought about that or whether that could be something. It wouldn't be so directly related to say the value of the land in terms of potential exploration, but it could be related to say the amount of economic activity currently going on there, and therefore if you were to then turn that into protected area, the amount of economic activity that might be lost. Yeah,
that's a great point as well. So the human density map, the population density maps, is actually based on a country's population density, and then they sort of weighted by the nightlight density. So it's sort of reflected inside already. Yeah, but that's why we lumped it into the overall like socio-economic as just human population, because it's hard to sort of segregate some of these out.
And just if you manage to do it, if you manage to get like an assessment of the economic value of that land, would you then maybe be interested in doing like, I guess you have a cost effectiveness perspective, but you could also, if you want, maybe you don't want to go there, but cost benefit perspective, where you could try and look at say the value of sequestered carbon in terms of not necessarily current carbon prices, but like say social cost of carbon, and do something, which would be a very sort of simplistic comparison of these kind of costs and benefits, but it could be interesting maybe.
Yeah, very interesting. And I hope to, but the next time I come back, I hope to be able to present something like that. We are working on it currently. So that will be quite exciting when we have some interesting results to show. Yeah,
Thanks very much.
Thanks.
I think you.
Was I first?
You were.
Okay, okay, cool. So just going back in time where you spoke about the difference between the 30% to 50%.
Yeah.
So I thought that was really interesting, comparing biodiversity, carbon, and the last one was number.
Yeah, nutrient regulation.
Nutrient,
Yeah.
okay. So I would like to ask whether there's like a threshold for those three metrics, whether, because as you said that as the area of protected areas increases to 50,
Yeah.
it kind of optimizes for the ecosystem services, but biodiversity was already kind of met at 30.
Yeah.
So do you reckon we need to like have 3 different targets to achieve those 3 different things, or is there a threshold to achieve those 3 outcomes?
Oh, that's a very good point. So I don't have the figure here, but in the I think in the original publication we actually had that curve that shows where it plateaus at as we increase the amount of protected areas, or protected area coverage rather. I can't remember what the threshold was off the top of my head, but of course, as you can tell, it plateaus much earlier for biodiversity compared to the ecosystem services. That's just because of the way it's calculated. It takes, because it's a polygon-based calculation, it tends to be more binary, so it plateaus much faster. The whole idea is that maybe if we try to go with like the second method I talked about, the area of habitat, that might help a little bit. But again, we are measuring in terms of the number of species gained. That's why it's more, it'll follow a different distribution. Yeah. As so the question of whether or not we need different goals for different sort of outcomes that we're trying to model for, maybe that's a very thought-provoking question. I think ideally maybe, right? But in reality, I think the way a lot of these policy framework plays out, it's they like things to be a bit more broad stroke. They want people, I mean, they like simple numbers.
Yeah.
Right? That's what I've sort of found out over the years. It's like if you have simple numbers, then it's easy for people to take in and understand. The more sort of tiered and nuanced system of conservation tends to be nice for underground conservation, right? Because that's how it happens. But for the large scale policy and to try to motivate people to be like, yes, I want to invest in this, I want to do this for my country. I think that so far it seems like simpler numbers and one single target actually is the easier way to go. Yeah, I'm not sure if that really answers your question.
Yeah.
Jonathan, did you have a question?
Yeah, I did. Thank you for the talk as well. It was a great talk, Yiwen. So in addition to cost, I reckon in most countries there's quite substantial constraints on where new protected areas can go due to things like land ownership, land rights, politics, institutional factors, a whole range of things. And I reckon they would strongly influence the trade-offs between the different values.
Yes.
But it's hard to measure because it probably varies a lot from country to country. But I wondered whether you thought about how you might capture those constraints and the variability amongst countries.
Yeah, so the easiest way to calculate some of this is that if concession data is readily available, if, for example, land titling is readily available, that would be great. For most of Southeast Asia, which is the area I tend to work around the most, it's not really there. There are some concession data on like Global Forest Watch, but it's sporadic. It's a bit haphazard. There's no systematic way of trying to understand the information. There are some efforts, especially in Indonesia, to have good land titling recognition, and that would be a nice way forward. But I haven't been able to download the data yet. But I think it is promising and definitely something important to take note of. And if we can incorporate it in some of these global or maybe regional estimates, we would make a little bit more sense. That's a good way to think about it as constraints on where it can be implemented. But even then, I would say, like for example, the Indonesian land titling efforts, a lot of these areas are community managed forests or can be community managed forests. So even then, there's a bit of a gray zone in terms of what can be counted as conservation, towards conservation or towards a 30 by 30. Right? How far do we want to lean towards, all community managed forests should count, or there's always going to be a huge gradient and a huge range of diversity in how land is managed. Yeah. Not really answering your question, but
Yeah, no, it's more a comment really.
Yeah.
Yeah, I think it's a challenge you have to do.
yeah, for sure.
I mean, it's the trouble with the top down projects, right? It's
Yes,
sort of bottom up drivers too.
yeah, but bottom up is also extremely difficult to measure.
Should we have one more question from the room and then throw to you, Kate?
First you.
Thanks for the presentation, it's amazing. I think I got this right. In your first study that you presented, you were limiting or requiring the 30% protection to be achieved within each country.
Yes.
Did you explore what happens if you remove that constraint in terms of how many more species you could protect and where you would maybe put that protection if it was a global goal rather than a national scale goal? I ask because I work with a lot of mining companies who are also committing to things like 30 by 30, but they're not going to be constrained to achieving that within any country. They're able to contribute towards lots of different countries' goals and constantly looking for new tools and trying to prioritize these things.
Yeah, that's a very good point. The simple answer was no, because when we did the work, COP15 was not over yet. And at the point of time, it was just places like the US, like China, announcing that they will protect 30% within their territories. So that was what we were really driven by. And I think logically, at the end of the day, that will be sort of how it plays out on a country level. But you're right, when it comes to mining companies, when it comes to companies in general, that have an international presence, they will probably have this ability to sort of find where the greatest outcomes are. But I think the competition comes on double counting or when that falls within the country's jurisdiction versus the companies. That would be really interesting to figure out as well because it's almost like what we see with companies and countries' climate goals and the potential for nested or double counting effects. Very cool.
A question from the chat from Pauline Revelant. Great presentation, thank you, she says, and she asks, why did you choose nitrogen regulation for an ecosystem service? Do you know if there are any payments like carbon credits but for nitrogen?
Yeah, so thank you for the question. The closest we have to that is payment for ecosystem services for water quality, and that was sort of what it was centered around. The nitrogen portion of it is just based on, again, data availability, what we could model. But there have been similar things proposed before. It's just that I don't think there's a proper active working market for it currently, especially not one that is beyond a very regional level. Yeah. Thank you.
I'll just jump in there with a quick question. So I noticed a huge jump in when we went from 30 by 30 to 50 by 50 in terms of nitrogen regulations. It was 47% to 87%. Do you know what the reasoning is there?
Yeah, it's basically the curve I was talking about earlier. Currently we are pretty low down that curve and we are far away from that plateau. So, but once we hit 50%, it's on that sharp increase on the curve.
Yeah. But what areas are particularly getting protected that are helping with that nitrogen regulation?
Oh, that's a good question. I can't remember offhand. It should be mostly forested area.
Yeah.
That's fine. From my memory, I think a lot of it would lie more towards the northern hemisphere. Yeah.
Any other questions?
So how does indigenous knowledge factor into the protection of the different areas globally? Because like for Australia and also for Canada, India, like there are a lot of areas where the communities are managing the various endangered species as well as interacting with them in terms of ecosystem services. So how does the indigenous knowledge factor into that?
Yeah, thank you. That's a great question. So currently the database that we have from WDPA, which is the World Database for Protected Areas, that includes some OECFs, which includes some indigenous lands and local community managed areas. But if you actually pull out the data to see it's pretty sparse. I mean, total there's only 800 plus areas that are recognized, and that includes other forms of protections as well. I think, especially for most other parts of the world, as we try to ramp up towards 30 by 30, we can't just rely on general like areas that nobody lives in, right? The rock and ice kind of thing. Especially for places like, I'm more familiar with Southeast Asia, but areas like Southeast Asia, we would hit a lot of community managed areas, whether formally recognized or not formally recognized, but there's a lot of local people and indigenous people living in the area and providing some degree of protection. I think that's sort of where the research would go towards in the future, but currently there's not a lot of information. No. As I mentioned before, a lot of the recognition of land rights and stuff like that, it's things that people are trying to work on and have been trying to work on for years. But it's still very great in terms of its recognition by, number one, the local government, as well as the regional policies itself. I mean, I think in COP15 itself, people were actively pushing towards that, trying to get increased recognition, but it's an effort and it's, I think, just starting, or starting to pick up speed. Yeah.
Thank you.
Can I ask a question about, so you use the PAD data to indicate the management effectiveness or something?
Yeah.
So how does it, can you give me some more information about that? How does a PAD event indicate the management effectiveness of a protected area after the PAD event has happened?
Yes.
And was there enough data on PAD events to be able to inform the effectiveness of the PAs for all of those species that you were looking at?
Okay, very good question. So this is getting into the PAD database itself. I'm sure you're aware it's an extremely messy data set to work with. Yeah. So the whole idea is that the PAD events represent a loss of protection, a loss of legal status, and we went with that as a key indicator of a loss of effectiveness. Obviously, when it comes to PAD events, there's a lot of reasons for it, including returning of land rights to local communities, right? But by and large, the greatest contributor to PAD events is industrial activity within the area, be it mining, be it deforestation, be it agriculture, right? So that's what we were sort of going with. Basically, when a PAD event happened in a protected area, it's an indication of that change. And we had actually broken it down to the different causes as well to try to understand it a little bit better. The other part of it was, did we have enough data to represent? So we sort of had to treat the PAD database separately because there's a time mismatch between the WDPA data set. So some of the PAD events were already removed from the WDPA data set, and some of them, they exist in both data sets. So it's still considered a protected area here, but in the other data set, it says it's no longer a protected area. So there's that mismatch as well. The simple answer is I spent a lot of time going through the data set to try to clean it up, to try to like develop some rules for some countries versus others and figure out what is transferable and what is not. But after we cleaned it up, yes, there was enough data. Yeah, it's we published it in Science Advances in 2022, but this year.
The database.
No, I think the data might be there. Remember, I can always send it to you.
Just a quick one, thanks again for your work, but I was wondering if you had considered including reptiles like lizards and snakes, or if they're just not charismatic enough, or if they are represented sort of like you won't get any extra data in terms of information that you acquire, maybe it's just data deficient, or was it considered?
Yeah, this is a great question. I like reptiles as well. So the first part of the work, the 30 by 30 portion, that did not include reptiles. But actually for the second portion, the area of habitat, I included reptiles for that as well. The reason is because the data for it was released in between the two projects. So basically IUCN was like, oh, now we have all the reptiles mapped out and all the reptiles represented. So when I moved on to the next project, I included it. Yeah.
Any other questions online? Any others in the room? Okay,
Just a really quick one. Have you or anyone in your team kind of thought about using these methods in the marine realm or is something just doing?
Yeah, great question. So far more towards coastal than pure marine, just simply because it's hard to find good geospatial data for marine areas. I think one of probably the best mapping data sets we have is Greg Exner's coral reefs for Hawaii. But again, it's only Hawaii. If you try to do similar things for Southeast Asia, or the water does not allow it to happen. The water's too murky. A lot of mapping is really bad in the region. Yeah, the marine areas. But yeah, I would love to. We're trying to get towards the coastal areas more. Yeah, with some projects. But work in progress, I guess. Yeah.
okay, well, we might wrap it up there. Thank you, Yiwen, that was fantastic, really interesting, and yeah, please, thank you very again.